Hello everyone. In today's lesson, we're going to learn about compound interest. So in the last lesson, we were talking about simple interest. What is the difference between simple interest and compound interest? Well, the main difference is that with compound interest, when you get interest, you don't just get interest based on how much money was initially invested. You also would get interest on the interest that you receive at the end of every amount of time that gives you interest. So let's say you're getting interest at the end of the year. The next year, when the interest is calculated, you would actually get interest not only on what you originally invested, but on how much new money was in the account based on the interest you got that first year. So you get interest on interest. In simple interest, that's not the case. In simple interest, you only get interest on the original amount of money invested. Now, you'll notice in this red box here, I wrote initially invested or borrowed. There are scenarios where you do get compound interest on loans as well. So it can work against you because sometimes you have to pay interest on interest when you borrow money, for instance, with some types of credit cards. But most of the time when we talk about compound interest, we talk about investing money. So let's jump right in with an example, and I'm going to use the exact same example setup basically as the last lesson. You invest $100 in a GIC. Now, what is a GIC? So before I get to the rest of the question here, there are multiple ways of investing money in the banking systems. GICs are called guaranteed investment certificates. These are things you can go into the bank and say, I'd like to buy a GIC, and it's an investment that is guaranteed. If you invest in stocks, stocks are not a guaranteed investment because stocks can go up and go down. But with a GIC, the bank is saying, okay, you're going to give me this money, and I'm going to keep it for the length of time that you've told me, and you're not allowed to take it out. And if you do take it out, you're going to have some heavy penalties. You're not going to get all of the interest that you should have gotten. In fact, you might have to pay some of the money back. So it's a good way of investing, but you have to be willing to get rid of that money for a while. All right, you won't be able to get it back. So, and they can, because the bank is doing that, they can often offer you higher interest rates. Now, I'm using an interest rate of 10% and an investment of $100. As I mentioned lower down here, this is not a realistic scenario. You will not get 10% interest on anything, pretty much. Maybe on mutual funds and stocks and bonds, which we'll talk about a little later. But most banks will not offer such a high interest rate in these times, okay? But I use these numbers just so that they're a little easier to understand for our first example, and they match the numbers from the previous lesson. So that's what I wrote here. Same starting values as the simple interest scenario from the previous lesson, but I just explained that they're not realistic numbers. So just like we did with our previous lesson, I am going to start with a table, okay? Because it's always good to see how are things changing one step at a time in a table before we jump to a formula, because the formulas are all based on the table, all right? So the way the table's set up is you've got your time in years, and I probably should have written the unit here. You've got your interest amount that we're going to calculate separately, and then you've got your final amount that you're going to have in the bank. So 0 time means this is your original investment of $100. Now, you'll notice one thing that is stated in this paragraph, which I didn't completely read. It says you're investing $100 at 10% per year, but then it says compounded annually. And this is the main difference with these questions compared to simple interest questions. With simple interest questions, they won't sometimes even tell you that it's a simple interest question. They just won't say compounded by a certain amount, okay? We're going to see later that could be compounded monthly, it could be compounded weekly. There's a lot of different ways that interest can be compounded, and that's just telling you how often is the bank giving you the interest. So compounding annually means at the end of the year, you would get your interest added to whatever you invested, okay? So that's why the time value here is in years, because it is compounded annually. Now, just to talk about something else you might see in documents from the bank, if you ever go and invest money or even borrow money, you might see the words per annum on your contract. Okay? Sorry, that looks like an M. Per annum. Now, what does per annum mean? It means annually in Latin. And because the language of education used to be Latin a long time ago, some of those traditions have stuck. So you might see per annum. You might see PA, which actually means per annum as well. That just means annually. So just a heads up there about what might happen if you actually go invest money at the bank or borrow money at the bank. So what you're going to notice is the way of calculating interest is kind of similar to what we did in the last lesson. Okay, so to get the interest going into the next year, we're going to take our $100, we're going to multiply it by 10%, okay, and I'm going to multiply it by how much time has elapsed, okay, which is 1 year. So what are we getting here? We're getting 100 times 0.10, like I showed the other day. When you have a percentage, you change it into a decimal, times 1. Well, times 1 doesn't change anything, so I'm just going to leave it like that. And our interest amount is therefore going to be $10. Okay, so I'm not adding it to the total amount yet because I'm going to need this for later. So I'm putting the interest amount only right here. All right. So what is our final amount going to be? Well, we're going to add these two numbers, 100 plus 10, to get $110. Okay. So here's where things are going to change. To calculate my next interest amount, and I'm going to change colors here so you can see the difference. In simple interest, we would have just taken the $100 again, multiplied it by 10%, and gotten another $10. But in this case, what we're going to do is we're actually going to take the $110 and multiply it by 10%, which is 0.10. Okay? Now, if you use your calculator, what you're going to get for that is you're going to get $11. So my interest rate for the second year is higher than the interest, sorry, not my interest rate, my interest amount for the second year is higher than the interest amount for the first year. It's $1 higher, which might not seem like a lot, but it is higher, okay? So now, if I take my final amount from the previous year and add it to my new interest amount, $110 plus $11 is $121. And then we do the same thing again. I'm going to use red for this one. So $121 now times 0.10, which is our 10% interest. What does that give? Well, with your calculator, that'll give $12.10. So if I put the $12.10 here as my new interest amount, again, you can see that my interest amount increased, but it isn't even increasing by a common value. Like it went up by 1 here, and it went up by 110 here, which means the next year it's probably going to go up again. And my total amount would be $133.10. So in my simple interest scenario, I would have had 110, 120, 130. In this scenario with compound interest, I'm already $3.10 higher than the person that was investing at simple interest. So compound interest, because you're getting interest on your interest, is going to give you a higher amount in the long run. And that's why people invest this way. Okay? And should. I mean, if you've got an extra $10 in the bank at the end of the year, the bank should be giving you a little bit of extra money. Because remember, the bank takes that $110 they invested and make a whole bunch of interest higher than you do. Let's say they make 18% interest on their investments. They're going to give you a small little fraction of that. Okay? So you should get a little bit of money extra for that. Now, if you did your first differences, we did first differences yesterday. I'm not going to write them in because I don't want to erase all these calculations, but if you did your first differences, you can see that your first differences would not be constant. And that means this relationship is not linear. Without taking too much time, because we've already done the background knowledge of this, if we did our first ratios would be constant, and our first ratios being constant means that this is an exponential relationship. So we're going to jump right to the formula at this point. And here it is. This is one of the most important formulas that you're going to see in mathematics for the real world. And everybody's going to need to understand this formula because this basically controls how you invest money. Now, I'm not giving you the whole story. This is the start of the story, okay? There is a more important formula than this in investment, but you have to start at the basics, and this is the basics. So you have to understand this one before you can understand the more complicated ones. So let's identify what each one of these letters mean. We already talked yesterday about A and P. A stands for the final amount, and that has not changed. P stands for the principal. The principal is how much you've invested or how much you're borrowing. Okay? I and N are new, and the I that you usually see for this equation is like a cursive I. So I'm going to draw it like this. I wasn't able to find the right font for this one, okay, in the math program that I used, but for I, it's usually written as a cursive I, like that, like a backwards J almost, okay? And this stands for, it's not interest, okay? Capital I is interest. This stands for interest divided by compounding frequency. Now, I'm going to briefly explain what that means here, but I'm going to explain it in more detail in a future example, okay? So interest divided by compounding frequency means that if you're compounding annually, you're getting paid once per year interest. That one would go where the compounding frequency is. But if you were compounding your money monthly, your compounding frequency would then be 12. And like I said, I'm going to explain that a little bit better later on, but just to give you a little bit of heads up as what's going to happen here. So I is interest divided by compounding frequency. N, and I'm going to use purple for N. N is equal to the number of compounding events. Okay, so let me explain a little bit what this means, and again I'm going to explain it a little bit later in a couple of examples. What does number of compounding events mean? Well, if you're compounding annually, so let me write this down. If you're compounding annually, for 20 years. Okay, well, what does this mean? This means every year you're getting interest, but every year you're getting interest for 20 years. So how many interest payments overall are you getting? And that's what number of compounding events means. And another way of writing it would be the number of interest payments throughout the life of the loan. Okay? How many times did you get it compounded? So it would be once per year times 20. Okay? So that would be 20 times. So you're getting interest 20 times. All right? So that's basically what that means. And again, I'm going to do an example right now. We're going to talk about it a little bit more. And then in the last example, hopefully it'll make a little bit more sense as well. So A is equal to P times 1 plus I to the n. The final amount is equal to the principal plus 1 plus the interest per compounding frequency to the power of the number of compounding events. And this right here, because the n is an exponent, makes this an exponential relationship. Okay, because the power in the power is a variable. Okay, so the first thing I'd like to do is, in the last lesson, we actually calculated how much money would you have if you invested $100 at 10% interest for 20 years, simple interest. And we ended up with $300 total amount with simple interest. If we use the exact same example I just showed you on the first slide, so let me go back to the first slide for just a second. That was $100 at 10% per year compounded annually. How much money would we have in comparison to the simple interest one that we did with the exact same values of 10 and 10 of 110%? Okay, so we're just going to use the formula, and I'm going to show you how the formula works. So A is equal to P times 1 plus I to the power of n, and I always get my students to calculate I and n before they do anything else. Okay, now I and n are very easy to calculate in this case. I is 10% divided by the compounding frequency, which is once per year. Okay, and again, I'll explain that a little bit more in the next example. Well, that's just 0.10, because 10% is 0.10 divided by 1 is just the same thing. Okay, now what is your n value? Your n value is the number of compounding events. So if we're compounding every year for 20 years, that's going to be 20 times 1, okay, which is 20. So let's put all of the numbers into our formula now. We have a principal of 100. We have a little I of 0.10, and it's just coincidence in this case that it matches the interest itself, to the power of 20. And I'm just going to put a little squiggly line here to show that this is calculations we did to the side. And now we have to type that into our calculator, all right? So I'm going to pull up the calculator right now. So we're going to follow the exact format of what our question was. So 100 times bracket 1 plus 0.10, close the bracket, to the power of 20 equals. And in simple interest, we ended up with $300. With compound interest, we end up with $672.75 approximately. So $672.75. And that's all done in one calculation. Okay, whereas at simple interest, we often have to calculate the interest first and then add it to the principal to find out our total. This gives us our final amount. Now, that does cause one little issue, because, okay, before I do that, the first thing I'd like to discuss is, wow, how much more money did you make compounding your interest, okay? Compared to $300, you made, you know, $372 extra, all right? But what if, as a part B to this question, I said, how much interest did you make? So in simple interest, we would have had that calculation first. In compound interest, we get our total value with interest at the end. But what if I asked you how much interest did you actually make? Well, how much money did we invest? We invested $100. Okay, this was our original investment. So all we have to do is subtract those two numbers. So if I do 672.75 minus 100 is equal to $572.75. That is the calculation for your capital I, which is how much interest you actually made. Okay? And I want to remind you that this is not a realistic scenario. Very few investments give you 10% per year compounded annually. Okay? But it's to demonstrate with easier numbers the difference in the power of compound interest compared to simple interest. Let's go to I believe our last example. And in this example, and we're going to do more of these in the next lesson, but this example is going to explain I and N a little bit better. Okay? So what happens if the compounding frequency is changed? So here we have a $5,000 investment in a mutual fund that gives 4% interest compounded monthly. How much money will you have in 10 years? So the first thing I'd like to mention is this is compounded monthly. Okay, so the previous example was compounded yearly. We're going to soon talk about what does compounding monthly change. The other thing I'd like to discuss is what is a mutual fund. Now, I'm not a banker, but let me try to explain what a mutual fund is. A mutual fund is a way of investing money that basically, instead of investing in stocks, now what is a stock? Just to be sure everybody understands a little bit about investing stocks. Stocks are companies that want to start out usually, and they need capital, they need money to be able to start their business. So they have a really great idea, and they say to everybody, hey, if you all give me a little bit of money, like let's say everybody gives me $100, that's going to help me start my business. And if I ever do really, really well with my business, I'm going to give you a little bit of interest back from that $100. That's what a stock is. Okay. So if let's say 1,000 people invest $100, that's $100,000 that company would have to, do with what they want to try to get their company started. And let's say that company gets really, really, really good sales and does really, really well. They might say to all of the people that invested 100, well, now we can give you actually $200 back instead of the original $100 that you gave us. So that's basically what a stock is. The problem is, if that company doesn't do very well, you could lose that $100. So it's risky to invest in singular stocks, like one company. So what banks have done is they've created groups of companies called mutual funds. And a mutual fund could have and again, I'm not a banker, but let's say it could have 1,000 different companies in it. Well, if you're investing in 1,000 different companies, if one company goes bankrupt and the other companies all do well, your money is still going to go up. So that's basically what a mutual fund is. Okay. So just explain what the language in this question means. So as soon as you see compounded monthly, or the word compounded specifically, I want you to immediately think of this formula. Okay, so that's the first thing you should always think about is it's a compounded monthly scenario. What is the formula for compound interest scenarios? And that's the formula. Let's talk about I and N before we do anything else. Okay. So how is compounded monthly going to change how I is calculated? Well, I've given you the formula for I, but let me try to explain this with a little bit of a diagram. So I'm going to draw a line here. I'm going to put I equals question mark. Okay, so we're calculating I, but I'm doing it with a visual representation. So the bank is giving you 4% interest. Well, pretend that this whole line is 1 year. Okay? you're going to get 4% interest at the end of the year. But the bank is going to split up the year into monthly values. So that means split up the year into how many different spaces. Well, how many months are there in a year? There's 12 months. So I'm going to do this in a very strange way here. I'm going to say 6 months is here. And now I have to split this up into 3 equal sections. So it just helps me kind of visualize how big the section should be. And I should have 3 equal sections here. So this is my first, and that's 6 months, right? And then I'm going to divide it. So 1, 2, 3, 4, 5, 6 months. So I'm going to divide that in half again. And now I have 12 months, okay? So the 0th month would be here, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right? So we're getting 4% at the end of the year. So what does compounded monthly mean? Well, the bank is not giving us 4% every month. They're giving us a little piece of the 4% every month. How do we calculate that little piece? Well, there's 12 sections, so we're going to divide 4% by 12 for each section. And that's how much interest you're getting each month. Now, if we continue doing that all the way to the end, at the end of the year, that total, if we add up all of those numbers, would add up to 12%. Sorry, my mistake, 4%. Sorry, the 12 here is throwing me off. So if we add up all of those 4% divided by 12, they'd actually end up adding to 4%. Okay? But what's interesting is because you're compounding your interest every month, what actually ends up happening is it's almost as if you're getting more money than 4%. Because the interest that you gain here, you gain more interest on that interest in the second month. And in the third month, you'd gain more interest on that interest again. So it technically almost ends up being more than a 4% per year if it was compounded yearly. Okay, so compounding more often actually gives you more money. So this is what I meant, and I'm going to rewrite it again, that I is the interest divided by the compounding frequency. Okay, because if you're compounding monthly, the bank is taking your 4% and dividing it by how many times per year you're getting that interest, and in this case it's 12 times per year because it's monthly. And now we actually have to calculate that. Now 4% is 0.04 as a decimal. You're dividing by 100, which means your decimal is moving 2 spots to the left, and there's a blank space there that gets replaced by a 0. Okay, so 0.04 divided by 12. And this is going to be a very, very small amount. And this is why I introduced scientific notation. I don't know if it's going to happen here, but this is why I introduced scientific notation a little while back, because sometimes the answer you get on your calculator in a case like this will be in scientific notation. So let's see what happens on our calculator. So let me clear this out. I'm actually going to delete that, so we got a clear history. So I want to do 0.04, sorry, I just messed up there, be careful. 0.04 divided by 12. So this would not give you scientific notation because most calculators can handle this many decimal places, but you could potentially see an E show up here with a negative number, which would mean times 10 to the negative number, which means a decimal value. So let's round this off to 0.0033. Oops, sorry about that. So this is going to be 0.0033. Okay, very small interest amount, but remember we're getting that every month. And at the end of the year, it would add up. If you multiplied this by 12, now I did round it off, but if you multiplied it by 12, you'd get your 0.04 back. Okay, so at the end of the year, you are going to get 4% interest. In fact, it'll behave like it's more than 4% interest because of the compounding scenario here. Okay, But you don't actually have to know all that. The formula is going to take care of it. Now, what is N? N is the number of compounding events over the entire life of this investment. So the first thing we got to remember is that we're doing this 12 times a year, but we're going for 10 years. Okay? So we're going for 10 years. The 10 years is what's going to be used in our N value. What do we have to multiply that by? Well, we have to multiply that by how many times per year, which is 12, that we're getting interest. Okay? And this is where I need to talk about understanding a question versus just following the steps. Because I cannot tell you how often my students will mistakenly multiply by 12 in I and divide by 12 in N, because they're different. They're both the same number. You do something with 12 in I and you do something with 12 in N, but you have to remember that I is divided by 12 and N is multiplied by 12. And if you understand why that interest is a total amount divided up by how many little chunks you get throughout the year, and N is how many interest payments throughout the entire life of the loan, and the entire life of the loan is 10 years, but you have to multiply that times how many interest payments you get per year. I'm hoping that you won't make that mistake, okay? And N ends up being 120 in this case. So that was a long explanation. Let's just go back to the original question and read what we were doing in the first place. So it says you invest $5,000 in a mutual fund that gives 4% interest compounded monthly. How much money will you have in 10 years? So I've explained what the word mutual fund means. I've now explained how do you work with the interest of 4% compounded monthly. You're taking your 4% and you're breaking it up into 12 equal payments, so you're dividing 4% by 12. That's your I value. How much money will you have in 10 years? Well, in 10 years, how many interest payments will you have if you compounded monthly? You'll have 10 times 12. How much money did we originally invest is 5,000. That's our P value. And now I have everything I need to fill in this formula, which we're going to do now. So A is equal to 5,000 times 1 plus I, and I is 0.0033, all to the power of 120. And let's type that into our calculator and see what we get. So again, I'm going to clear this out. I'm going to delete the history so nothing is in there. Okay. So we've got 5,000 times bracket 1 plus 0.0033, close the bracket, to the power of 120. And we'd end up with $7,424.50. So our final answer here is $7,424.50. Once again, if I asked how much interest, you would just subtract the principal from that amount. So $7,424.50 minus $5,000 is equal to $2,424.50. And that's how much interest you would have made compounding the way we said in this question. So just to show you what would happen if you compounded annually at 4%. Okay, so remember up here I was saying that compounding monthly and adding up to 4% at the end of the year actually kind of works out where you're getting more money than you would if you just compound at 4%, just to show you what it would look like. And I'm going to do the calculation pretty quick, okay? So compounded annually So your A would be 5,000 times 1 plus, because it's 4% divided by 1, it's just 0.04. And because it's annually, it would only be the number of years that have gone by. So the number of years, if you remember, was 10, okay? So let's compare what our answer would be here with what our answer is previously. So 5,000 times bracket 1 plus 0.04 bracket to the power of 10. And that gives $7,401.22. So it's not a huge difference, but it is a difference. Okay, it's a smaller amount. And it's smaller by how much? $23.50? No, not even. Okay, so so compounding more often, even though it's the same interest rate, 4% at the end of the year, okay, compounding more often gives you more money at the end. And that's the power of compound interest. And that is how people can save up enough money to retire. If they start putting money away as early as possible into the right kind of investments, and there are multiple different ones which we'll talk about in a different lesson. I'll give you a hint. RRSPs, you might have heard of those. RRSPs are registered savings plans, registered retirement savings plans. So those are investments that people invest in for their futures. And they don't work exactly on this concept. It's a little bit more complicated, but this is the basics of how they work. Okay? So the big takeaway from today, folks, is the formula for compound interest. Understanding that I is the interest divided by the compounding frequency. So if you're compounding monthly, and we're going to look at more compounding frequencies another day, because you can compound weekly, you can compound bi-weekly, there's a lot of different compounding frequencies, that you have to divide your interest by that compounding frequency for I, and N is the number of compounding events, which is usually your number of years times the amount per year that you're compounding, okay? If you can start to kind of get how this formula allows us to solve this kind of problem, especially calculating I and N, I'm going to repeat it one more time, then you won't have any problems with this section. So that's the end of the lesson for today. I will be posting some homework questions in the Google Classroom. So if you have any questions, please email me the questions, and I will try to somehow get you the responses to those questions as soon as possible. Have a great day, folks. We will see you in the next lesson.